Hello, ninth graders! This is Teacher Raquel A. San Juan of Urdaneta City National High School, and welcome to our virtual instruction. For this video lesson, we will be learning about angle of elevation and angle of depression, and also we will use trigonometric ratios to solve real-life problems involving right triangles. Okay, before we will discuss the difference between angle of elevation and angle of depression, let me clarify what a line of sight is. Line of sight is an imaginary line that connects the eye of an observer to the object being observed. So here, in this example, this is the line of sight. So it connects the eye of the observer to this butterfly which is being observed. Okay, here in the picture you can see an example of an angle of elevation. So this angle of elevation is the angle that is formed between the horizontal line and the line of sight of the observer to the object above. So as you can see here, we have a dog looking at the bird on the top of the tree. So the object being observed is the bird and the observer is the dog. Now the object being observed is above the horizontal, so therefore the angle formed is an angle of elevation. Next is the angle of depression. The angle of depression is the angle that is formed between the horizontal and the line of sight of the observer to the object below. So here, the observer is this pilot and he's looking at an island below. So the object that is being observed is below the observer. Therefore, what is formed is an angle of depression. So please take note of that. If the object that is being observed is above the observer, then the angle that is formed is an angle of elevation. Remember, this is the horizontal line. Now, if the object that is being observed is below the observer, then what you have is an angle of depression. Here are examples for activity 1. Picture it out. In here, you will identify the situation if it illustrates angle of elevation or angle of depression. So for example number 1, you have from the base of an observation deck to a flying helicopter. Now here, where do you think is the object being observed? The object that is being observed is the helicopter, and that is above the observer. So that means the angle that we have here is an angle of elevation. For example number 2, from the 5th floor balcony to the car parked on the ground. So the object that is being observed is below. It is on the ground and the observer is on the 5th floor balcony. Therefore, the angle is an angle of depression. Alright. Okay, for activity 2 challenge, you are going to solve application problems involving right triangles using trigonometric ratios. Now, before we will have examples for activity 2, let's just go over the steps on how you're going to solve those mathematics problems. Okay, first one, read and analyze the problem. Number 2, based from the description on the problem and the given information, draw a diagram. Number 3, determine the trigonometric ratio to be used. So it depends if two sides or an angle and a side are given. And then the last one is set up your equation and solve for the unknown. Okay, here is example number 1. A tower is 15.24 meters high. At a certain distance away from the tower, An observer determines that the angle of elevation to the top of it is 41 degrees. How far is the observer from the base of the tower? Alright, so after reading and analyzing, we have to come up with a diagram. And my diagram will look like this. I have a tower that is 15.24 meters high, and then the measure of the angle of elevation that is formed from the horizontal to the line of sight of the observer is 41 degrees. So what we're looking for is the distance of the observer from the base of the tower. So our unknown is here, x. Now, if this is our reference angle, this is our theta. This would be the adjacent side, and that would be the opposite side. So if we have an opposite side and adjacent side, then the trigonometric ratio that should be used is the tangent ratio. So we have tangent theta is equal to opposite side over adjacent side. Okay, substituting the given values from the problem, our equation will be tangent 41 is equal to 15.24 over x. So if we solve for x, we do cross multiplication, we will have 15.24 divided by the value of tangent 41 degrees, and the answer is going to be 17.53 meters. So therefore, the observer is 17.53 meters away from the base of the tower. Okay, next example. A girl on a hot air balloon 50 feet high sees a car collision at an angle of depression of 34 degrees. How far is the girl from the site of the collision? Alright, so after reading and analyzing, we are going to make a diagram. So we have a girl on a hot air balloon which is 50 feet high, and there is a car collision at an angle of depression of 34 degrees. Now the question says, how far is the girl from the site of the collision? So we are looking at this distance here. That is our unknown. Alright, now in order to solve this, I have to enclose this part right here to complete a right triangle, and do the same thing on this side right here. This is parallel to this side, and this is also parallel to the bottom side. Now, since these two lines are parallel lines, and this line here acts as a transversal, you will notice that these angles are alternate interior angles. Therefore, the measure of this is also 34 degrees. Now, if I am going to make this my theta or my reference angle, then this is going to be the opposite side, and the unknown here is the hypotenuse. And if the opposite side and the hypotenuse are involved, then the right trigonometric ratio to be used would be the sine ratio. So sine theta is equal to the opposite side over the hypotenuse. Okay, if you are going to substitute the given information, our equation is going to be sine 34 degrees is equal to 50 over x. So dividing 50 by the value of sine 34 degrees, we will get the answer 89.41 feet. So the distance of the girl from the car collision is 89.41 feet. So that ends our video lesson for this topic. Thank you for listening and paying attention. Bye!